Hi, I'm Brian Segnet with Xerox, and I'm here with Michelle Fornell, the Senior Systems Engineer on the Versant program. And what we're going to do is have a look under the hood, and we're going to have a look under the hood of the new Xerox Versant 3100 press. So, Michelle, we know a lot of things about the press. We can do 350 GSM. We can run a duty cycle of 1.2 million prints, average monthly print around 250,000. One of the big things is registration. How do we get it on this press? Can we look under the hood?
Yep, let's take a look. Okay, we all know the paper come from, on the Xerox product, come from left to right. Okay, so the first thing we do coming from tray 1, 2, 3, or one of the high cap feeder from tray 6 and 7, or 8 and 9 if we have a dupe tandem high cap feeder, the sheet come in, and as you know, our paper path is pretty straightforward, the entire length of the printer going to the finishing device. So what we want to make sure that when the paper comes to the pre-registration assembly, that we are set and we measure the exact position of the paper. So what we do is, we have many sensors to be able to accomplish that matter, okay? And there's a little gate here, when the paper come in, it goes up. And then ensure the paper is straight and flat against that edge.
So much like a head stop on an offset press, so I'm going to manually or physically register that piece of paper.
That's correct.
And then the contact image sensors are?
They're located on top here, okay? And again, many sensors are in function to ensure you got the lead edge, the inboard side, the outboard side, and then we measure all those coordinates.
So nice straight paper path. I know that on the Versant 3100 we have half a millimeter registration, right?
Yep.
So plus or minus half millimeter, that's skew, magnification, perpendicularity. So that's pretty nice.
And magnification.
And magnification.
Yep.
Excellent.
So at this point we know exactly what the piece of paper is, and then we measure this every print, every sheet coming in.
Every sheet?
Yes. Then this information is sent back to the controller of the printer in the back of the machine. This information is calculated and transformed to the ROS, the scanner assembly, ROS laser assembly. And then at that point, we start to write the images on the drum. Okay, so you get the toner on top here. Okay.
Okay.
And
so
right
I've got my
underneath
toners,
it,
right?
okay. The reason it's there because we trickle down the toner and the developer.
Okay.
The lasers are located under this cover here. And if you notice, there's four little spots here. This is where the glass is and where the light come down to be able to discharge the drum. Okay. The reason there's a little opening here that if for some reason the dirt get in there, you can come and clean it.
Well, that's really nice. So kind of a lot of self-maintenance features, right? Like I notice it's 5 o'clock at night and I've got to get a job out and I notice a spot, I can go ahead and I can fix that. Nice.
So this information from the laser is transformed right to the drums. There's a drum per color, okay? And then we start to get the image right on the drum, okay? If for some reason, again, you talk about maintenance, the customer notice a spot or a scratch, it can replace the drum in seconds.
So just pop it out, right?
Pop it out.
Again, a customer replaceable unit.
Okay.
Excellent.
So you get the drum here, you got the developer assembly here, which take the toner and mix it with the material, the developer material. And then this image is going right down on the next assembly, which is the IBT belt.
And I know these are light sensitive, so kind of do it kind of quick, right? Good.
Okay. Then the image is going to the image transfer belt. Okay. Then we're going to go back to our paper path assembly. So the image is on the belt, going around. Okay. Paper come in, and when they arrive at this contact point here, this image on the belt is transferred to the paper.
So it's actually written right to the paper there.
Correct. And it's called the second bias transfer roll.
Okay.
Okay. And then you do your best to explain this, how this works.
So a bias transfer biases electricity, right? So I'm gonna, zap that bias transfer, either give it more electricity or less electricity depending on the amount of image and the type of paper that I'm using, right?
Yeah. It's a little bit more complex than that, but it's roughly right.
For a marketing guy, it's a simple way to talk about it.
Yes, and you're learning over
And
years.
then the fuser, right? Our fuser is here, but what we can do is we get a 10-bit, and we're actually writing 4 times the amount of pixels on a page, right? So more pixels on a page makes for a better image, and it's fused right here.
So as all the xerographic product we have, we need to make sure the image is fixed to the paper. We use temperature, like a
So I'm going to use some heat.
Yes, and the good advantage of this is compared to the traditional roll to make this happen, we took the technology from the color press, which was a big giant
The
belt.
higher end, right?
Yeah,
Higher
and then
end press.
we shrunk it a little bit, okay, but the technology is still valid here to make sure you get very consistent heat around the belt, meaning that from page to page, from media to media, different stock, you can maintain this image quality solid. And the speed, and maintain that
So
speed.
that's nice. So mixed media, I can heat up, I can cool down,
Yep.
and even things like an envelope. Do I need? I don't need to change the fuser,
Same
do
fuser,
I? Same
yeah.
fuser.
Same fuser.
Same fuser. 350
That's
GSM.
correct. No need to go back and forth with different fuser.
Terrific.
Okay. Then we're going to go to the next part of the printer.
Yeah, this is kind of. I like to say this is where the magic happens, right? So this is the full width array.
I would call that more magic.
More magic, right?
Okay. So because we're going at the high speed of 100 prints per minute, okay, the prints are coming out, and if you make a print on a coated paper, and you get a lot of coverage on it, the toner is extremely hot, and if you make many prints in a row, they have tendency to stick together. So you need to remove. So we heat the paper, and then we need to remove the heat from it. So we have a module here called the cooling modules, which is two belts, okay, located here. The sheet of paper goes in between, okay, and the good thing about this material this is the same material as the IBT belt. It sucks the heat out of the paper.
So really,
instantly,
a
about
good
6 inches, distance.
good transfer, right? So it's going to
It's
transfer.
a reverse transfer of the heat.
Excellent. Okay.
Okay. Then we have a little heat sink here with a fan in the back, and we suck that hot air right out of the machine.
So my heat is going to go into that belt. I'm then going to pull it into this cooling block and
Send it out of the
right
machine.
out.
That's correct.
And I don't need to vent the machine to outside.
nope,
Terrific.
nope.
Yep.
The next component here is used for 3 reasons. Okay.
Okay.
So on the smaller device, we have a tool called the Sika tool.
Right. On
And we
the
can-
Versant 180.
Yeah, we can achieve a registration from front to back perfectly. We can do transfer image from side 1, side 2 also. And we can also do a density uniformity from inboard to outboard.
So, Michelle, we call that like a semi-automated process on the 180, right? Because I'm running a sheet and then I'm scanning it back in.
Yep.
More automated here on the 3100?
So yeah, so this one is called the FWA, the full width array. Okay. The scanner we have on the smaller machine is online, located right under this
right
cover.
in there, okay.
Yep. And then we use a LED process right in this location here. And then we have a roll here that before the machine starts, we will make sure that it's adjusted properly. We move this roll in position here, and we want to make sure white is white, okay? Because the paper is not always white. It can be bluish, could be yellow, could be porous. We want to make sure that we know what the white is. So we measure this from inboard to outboard.
Okay.
Yes, this information is sent to the scanner, okay, the FWA scanner.
So that kind of gives me my white point?
Yeah, yeah, and then I can measure this white point to any reading after a while.
Okay.
And then we move this location here, and we want to make sure that we know where the paper is height-wise. Okay, so we measure the lowest point of that roll.
So I can actually
It's like a little
feel,
steps.
right?
Yeah.
So that's stepped up. That's, you know,
you got
indented, and this
the
starts to
middle
kind
one,
of come up,
and
right?
then we do the same thing in the middle, and then the same thing at the inboard side.
So the sheet of paper is going to ride over top
Not
of
yet.
that?
So
Okay.
at this point, we just make measurement. Okay. Then we measure where this little Z here is. Okay. And then we're going to send a piece of paper in the machine, and then we're going to measure where the paper is traveling in the machine. So we will compare the edge of that sheet to the top of the Z, and then we're going to measure until the end. And then if at the end we're about 3 millimeters away, we know we have a skew of 3 millimeters from lead edge to trail edge.
Okay.
So all this information is put in the machine. Now I can predictly measure and change my image on the piece of paper to match side 1 and side 2.
I got it. So it's going to calculate it depending on how heavy that piece of paper is, whatever that size
Yep,
is.
yep.
It's going to send it across it, and that's how I get my great front to back
Yes, and
registration.
this is why we do 10 sheet. When we do the adjustment for the profile of the alignment,
Right.
we made 3 prints with the paper that we are using. We measured it, we apply the change, we make 3 more, and then we make calculation, we make 3 more to make sure, and then the 10th one is your final product.
So that's really terrific. If I'm cutting something front to back registration, I really want it critical. For the most part, the press is really going to be right in line. But if I've got a stock that's misbehaving because of humidity or temperature, or maybe even I cut the paper not exactly right, right? This is going to help me compensate for that.
This paper here, we printed this earlier. Okay, so this is when we do the same process. FWA is used to make the density inboard or outboard. Okay, so we're going to print those CMYK at 100%, 40%, and 20%.
Okay.
And we're going to measure, across and make the adjustment, and then send this information back to the controller.
So that scanner is going to read that information.
This information, okay, and make the adjustment to make sure we're even from both sides. That's why when we look at this, we always do this to make sure that we're even.
Right, because that's what happens. You print something maybe like a business card, and one side doesn't match up. It looks good on a sheet until I cut it, so that's going to fix that.
People always ask why I'm doing another sheet here. This one is called the RGB. RGB is only a mix of CMYK.
Right.
So when you start to mess around, I'm going to change the coordinate of magenta, okay? And I'm going to change the cyan. You mix them together, it's different color.
Yeah.
So when you start to mess around with those ones, you may make big effect on the RGB.
So it's going to read CMYK and RGB.
The RGB is just to verify your formula is correct.
Okay, great.
Okay. So this is what we make this one at the end.
Super.
That complete to the FWA.
Excellent. So we know that really gives you the level of automation on a Versant 3100 press, right?
Don't forget the big inverter assembly.
Oh, so duplex, because that's important, right? If I want to duplex 350 GSM, where does it happen? Right down in there?
Yeah, the inverter assembly is right. It's located right here. What we do is we just go this way and send it back in the process here. The reason we can run 350 GSM duplex is the radius is so large that we can afford.
You've got a lot of real estate. And one of the questions comes up, what's the difference between the Versant 180 and the Versant 3100? Well, it's 80 versus 100 pages, but there's a lot more automation here. There's a lot more real estate. This is much more of a production press. I'm going to do a lot more volume, and I have a much, much higher level of automation. Hey, Michel, thank you. It's great to have a look underneath the hood. We really appreciate it. Thank you. For more information, go to Xerox.com. We actually have a white paper on the Xerox Versant family of presses, and you can learn more about what's underneath the hood. Thank you.